MathClass101.com, Algebra, Solving Quadratic Equations by Factoring, copyright 2007 by InternetClass101.com. What I wanted to talk with you about in these next few lectures or video lessons is I'd like to focus now on a specific type of polynomial type equation, one where it has a specific form and a specific, it's equated to a specific quantity. It's referred to as a quadratic equation. And to start with, what I'd like to do is just write for you what a quadratic equation looks like. The quadratic equation has the first term, the highest power is 2. Here I'm using the variable x. The next term is the power of 1, x to the 1. The last power is a constant c, and it's set equal to 0. That is the standard form for a quadratic equation. Now, there are two main ways that people use to solve a quadratic equation. In this video lesson, I would like to go through how to use the method of what's referred to as factoring, and in the next video lesson I will show you how to use a method called completing the squares. And later I will show you how to, from the other method, completing the squares, how we will actually derive what's referred to as the quadratic formula. And the easiest way for me to show you what factoring is and how we can use it to solve a quadratic equation to find what the two values, the two values of x are, is to first get the factors, and then from the two factors get the two roots. And the best way to show you this is by example. So let's say we had a quadratic equation that was x squared plus 3x minus 10 equals 0. Okay? Sorry, the light's glaring on it, so I'm going to turn the light back out. Now, to factor this, we need to find out two terms, both in x, and the reason we know they're both in x is because the highest power is x squared, that when they multiply equals 0, right? Because we don't want to change anything on this side, and whatever we write here has to be completely, exactly equivalent to what's written there. Well, what can we tell from looking at this? We know we have two terms, and we know those two terms are going to have a number here, plus or minus there, we don't know yet. And we know that when those two numbers that are end up here get multiplied together, they give us negative 10. And when we multiply these two terms by each other, at some point we'll simplify and end up with positive 3x. So we know that. So what does that tell us? Well, that tells us what two numbers when multiplied together would give us negative 10, but when added together give us a positive 3. Well, I'll go straight to the answer, but if you think about it a moment, the answer is pretty obvious. The two numbers that would do that would be a positive 5 and a negative 2. And the reason is when you multiply positive 5 with negative 2, you get negative 10. And when you say positive 5 plus a negative 2, you get positive 3. I'll quickly multiply this out to show you that I'm correct. X times x is x squared. X times negative 2 is negative 2x. 5 times x is positive 5x. 5 times negative 2 is negative 10 equals 0. And see, I was correct. This gives us a positive 3x and a negative 10. So we now have our two factors. We have just factored this quadratic equation. Well, what do we also know? We have the two factors, so we can get the two roots. In order for both of these terms to multiply together and give us equal to 0, at least one has to be 0. So either this term, x plus 5, equals 0, or this term, x minus 2 equals 0. We don't know that both of them are 0, we just know that one of them has to be 0 in order to give us 0, because 0 times anything is 0. Well, if x plus 5 equals 0 here, what is x? Negative 5. If x minus 2 equals 0, what is x here? Positive 2. And we have just solved this quadratic equation. We have just found its two roots by using the method of factoring. And in the next lecture, I'll show you how to use another method called completing the squares. And then we will develop an equation that's referred to as the quadratic formula, so you can quickly solve these types of equations because they come up a lot. I'll stop there for now.